Alright everyone, welcome to Advent to Code Day 19. Here we are. 18 was a little bit of a refresh. We got a reset in. I still don't have all my stars. You can see day 16, I don't have part 2. I still don't have part 2 on day 17 either. I have the star, but I don't have the actual code working yet. But at any rate, day 19, let's do it. Your scan showed the lava did indeed form obsidian. The wind has changed direction enough to start sending lava droplets towards you, so you and the elephants exit the cave. As you do, you notice a collection of geodes around the pond. Perhaps you could use these obsidian, to create some geode cracking robots to break them open. To collect the obsidian from the bottom of the pond, you need some waterproof obsidian collecting robots. Fortunately, there is an abundant amount of clay nearby, and you can make them waterproof. In order to harvest the clay, you need a specialized purpose clay collecting robots. To make any other type of robot, you need ore, which is also plentiful, but in opposite direction for the clay. To collecting ore requires ore collecting robots with big drills. There's a lot of collecting robots. You have exactly one ore collecting robot in your pack that you can use to kickstart the whole operation. Each robot can collect one of its resource type per minute. It also takes 1 minute for the robot factory, also conveniently in your pack, to construct any type of robot, although it consumes the necessary resources available for construction begins. Robot Factory has many blueprints, puzzle inputs you can choose to form, but once you've configured it with the blueprint, you can't change it. You need to work out which blueprint is the best. For example, K. Blueprints have been line wrapped for legibility. The Robot Factory actual formatted blueprints are provided by okay. The elephants are starting to look hungry, so you shouldn't take too long. You need to figure out which blueprint should maximize the number of open geodes after 24 minutes by figuring out which robot to build and then when to build it. Using blueprint 1 in the example above, the largest number of geodes you can open in 24 minutes is 9. This is okay. You can is 12. So the first one was 9. Okay. Determine the quality level of each blueprint by multiplying that blueprint's ID number with the largest number of geodes that can be opened in 24 minutes. For example, the first blueprint has ID of 1, it could be 9. Quality level 9, the second one is 2, 12, 24. If you could add the quality, okay. Determine the quality level of each blueprint using the largest number of geodes it could produce in 24 minutes. I feel there's me not a ton. Okay. This feels like I'm missing something. This doesn't look too hard off the bat. Parsing this. Okay. Okay, so int colon equals, I should like make like some sort of auto parsing stuff because this is just annoying to parse every day. For string s in inputs. Ooh, not that. So our colon is going to be s dot index of this character here, and then what we're going to want to do is do string parts. This is going to be res. I call it res in. S dot substring from colon on, and then what we're going to do is we want to then let's trim this real quick just in case. And then what we're going to do is we're going to want our parts. So res input and split on the period. So this will give us the individual. Oh, it's regex, right? Right, regex. So what's that? So we have our individual parts, which means now we have like this. So now we need int ore cost. Each ore robot cost for ore. That's gonna be. Luckily, these are all 1, so I can kind of skip it, and I can just do 21. Integer parseint parts 0 char at 21. Okay, I'll find a substring. 21 to 22. That'll work. All right, so there is the ore cost. This is going to be the ore cost. That's actually what it is. The clay ore cost. The clay ore cost is at 22. Please tell me they're only all one. Good. Obsidian ore cost, obsidian clay cost. Whoops. Obsidian ore cost, obsidian clay cost. They're all single ore, so I can do 26. Oops. This is also 1. Ooh. Put on the wrong one. Clay, 2 and 2. And so that's going to be at 36. It's 36, and then parts 2 dot index of space after 36. And then same thing, but this is for geode. Last but not least. This is the geode ore and the geode obsidian. Three and 3. 23. It's all single digits. Life's easy. 23. And then I'm gonna guess it's the same thing. 33 to space. Okay, so now we have all the individual costs all broken away. I also didn't need, I haven't done this yet, so let me quickly do this. Make life easier there. Okay. And so we have all the individual costs. Now, what is this? So oh, but clay collecting, clay collecting. Oh, we can't build ore robots. Ah, okay. So maybe this isn't as bad. I thought we had to like kind of go back and forth, but no. Okay. So what we need to do is we will need a private class. This is going to be a blueprint. And we're going to need all this information. And I believe I can just create this from that. And then I'm trying to think of like how we can have the whole logic for everything, like all the step logic work. But so we can have a list of blueprints, new array list, K. This makes it easier. Now we can just do blueprints, add new blueprints. Clay, obsidian, obsidian, geode, geode. Okay, so now we have our blueprints done. So now we move on to the actual logic. So this is going to be, I guess, for blueprint B in blueprints. Each one has what, 24 minutes, right? 24 minutes for int I equals 0, while I is less than 24, I plus plus. And so we have these blueprints. So what we need to do then is we need a number of robots for each. So now let's get into, so we have now a separate public int or robots. These are all initialized by default. Or robot, clay robot, obsidian robot, obsidian robots, and geode robots. These are all at 0. So what we need is, we have this, then we need a public int or public int clay, public int obsidian, public int what's after obsidian is gonna be geode. I had to think about that for a second for some reason. So if you make like a public void tick, what we could do is we could do or plus equals or robots. No, because each or robot can get 1. Which, yeah, these can get their own, one of each their own resources. So or clay, obsidian, and geode. So that makes that easy. So now we can just do, you know what, blueprint tick. That solves that. Now all we need to do is, at the start, we need to figure out which ones we can make. Okay, so I'm gonna change this to kind of crush these down into 1. This is just gonna be robots. Whoops. I'm gonna crush these all down. Oops, not there. Into 1 big long list. And ores, or resources, let's call that. So for int I equals 0, while I is less than robots dot length I plus plus, and then we just simply just do resources I plus plus, or no, plus equals robots I. Okay, and the reason why I did that is because we're going to need a making, or so robots making, and I believe we want to always create the highest one first. So when we tick, what we want to do is we want to check if what's the cost? Oh, it's in blueprints, right. So if resources of obsidian, so 2 is greater than or equal to that, and resources of ore is 0, I think, but I should probably make a comment of this. Ore, clay, obsidian, geode. Okay, and that is greater than or equal to geode ore cost. So now we need to do robots making. This is the 4th one, right? This is, yeah, geode. So 4 or 3. Plus. I guess technically we could be. You can only make 1, right? It says you can only make 1. Yeah, you can only make 1 robot at a time, so that's fine. And this is where we then do this minus equals this, this, and oops, this. Okay. Obsidian clay. Clay is 1. Obsidian ore. Obsidian ore. Obsidian clay 2. And then it's just clay. That's it. And then last but not least is ore, which is 0. I don't think you ever make more ore robots, but that's fine. Just in case. 0, 0. Oh, it's 0, by the way. Clay ore, which is 0. Okay, and then after we process the resources, then we can do is again this robots I plus equals robots making I, and we gotta do 2 things here because the second step is then is to do I equals 0. And in theory, this will work. We just call tick. This does all the logic, and then when we're done, we can just go through and count the number of geodes we have. So we're gonna do int sum, or just call it value, sure. 0 value plus equals. Oh, I need these to be I because it's counting. It does the logic like that. And b or b equals 0. While b is less than or equal to b is less than blueprint size b plus plus. Blueprints. Because what we do now is we just do blueprint dot resources 3 times b and lap on value. And in theory, if I did this right, what you didn't apparently, for input s, this is the or. 21, is it? It's trying to get S? Okay, so that should be 23, 24. There's gonna be a lot of these. I feel like I messed up a lot of these. What? Oh, what the heck? Oh. That would be why. Yeah, a lot of these got messed up. Apparently my counting logic was not very good. Did I do all of these wrong? I must have done all of these off by 1. That's unfortunate. For input 7, what the heck? 7, there's a space. Oh, part 3. That'd be why. There we go. Please tell me it's the answer. No? Oh, this, of course, the input, the test input 2 is not right. Like, you gotta, like, fix it. What do I get? 13? That doesn't seem right. What do I get? 0 and 13. That's not right at all. Okay. Okay, what's going on here? After 24 rounds, what do we have? 2, 121. Okay. Sure. Clay. Am I not collecting clay correctly or something? Am I not collecting clay? Like, what's... I have 121 clay. Oh, because I'm stopping. I can't get to clay because I get to 2 ore. No, we do get into the chart of... Okay, so we do get into this whole... Okay, this I don't know how to do then. So we have the whole issue of you gotta know... Is it better to wait for more clay or better to wait for more... Okay. Uh, 24 minutes. Which roads to build and when to build them. I don't want to recursively descent. I don't want to do this whole recursive descent into figuring out when to build and the ticking and all of that. So this is the issue right here, is this tick. So this is all works. It's just the logic in deciding when to build a robot doesn't work. Yeah. I feel like I need some sort of like branching logic to know if I'm like gonna branch. I think we can ignore ore robots. Maybe we don't though. Okay, and return branch. So if it branches... So it branches, but how much we need to be, like, we need to have it skip those. We need to tell it to skip. I feel like we have to move this out of here. Put this into here. This is gonna all require a BP bit. Problem is this just descends though. This doesn't, we don't get the descent we need into recursion. Okay, put this back here. Okay, it's out of here. So what we need to do then is make a method for this. Public and get max geodes for blueprint B. Oops. So we know that. So what this comes down to is this branching. So we have a blueprint. We need a way to copy a blueprint from another blueprint, which is basically take all these values and copy it across. Because then what we can do these need a public int minute on them. So if I make a constructor here, basically just take all of these and dump it here. And so just copy them all across. That way we can then individually map them and individually work with them. Whoops, individually work with them. I think that's the only way to make this work. I can't think of another way to get this to work. This, okay. Okay, so we can now do this blueprint bits. So what we need to do is, I guess, move this into here. Anytime we branch, we need to branch it, but have it skip something. That's the problem, is having it skip this logic. So choose to do this or choose not to do that. Okay, so this can come out of tick. This doesn't make sense to have a tick anymore because tick is this. This is tick. And this goes from minute to 24. So this doesn't need to come in here because we can just call a blueprint. Call a get max from that. Okay, so we have this now. So we have these resources. So we need to know to skip. I guess we need a boolean here. So it's gonna be called skip new boolean 4. They'll be all false by default, so that's fine. And not skip on 3. And not skip on 2, and not skip on 1, and not skip on 0. So whenever we do this, we need to then firstly do a blueprint. New blueprint given this. We need a blueprint skip 3 is true, and then do blueprint dot get max geodes. And then if geodes is greater than max, max equals geodes. And I think this is how we're going to have to do it. This is the best I got. This isn't really gonna, I don't think it's gonna work, but so that works there, and then at the very end, oh, this is just max. But this is max as in this needs to be a while min is less than 24. Sorry, minute. Yeah, because you start here, so then return basically up to it, and then we still need to calculate the geodes from that. This is the max as it's added on. So this is the max of all of these. Problem is, how does this max geodes bit come in? If we were to skip it, that's how many geodes we would get by skipping it and doing a future one. How does this max work? This max doesn't go here. This max doesn't work like this. How does this max geodes work? No, it doesn't work. Yeah, it just doesn't work like this because it's not recursive. It's doing a recursive and doing this awkwardly. I'm missing some different math that this is supposed to be doing. There's supposed to be some sort of like a matrix table. Yeah, no, this doesn't work. How What if I can salvage this without doing this while loop? If I can get rid of this while loop, I might be able to salvage this logic. Because max just becomes blueprints. Does it if I can salvage it there? Each one's in charge of 1 minute. If I'm trying to like, this does a single minute, then we do this, we're gonna do int max equals resources of 3 and for blueprint BP and BPs can do this, and then we return max. Does this even work? Does this even work? So this adds all the blueprints. This adds the alternate paths, the alternate this adds the alternate how do you call it? Alternate decisions, I guess. Okay, so what if we do then one for this? No, wait, because we need to do minutes plus 1. Because yeah, we do that, so then it doesn't need to be actually technically done up there. It can be done anywhere. So if we do it down here, so then, well, no, we do it after this because this does the resource stuff, also does the resource kind of calculations, add a minute. Okay. Maybe that works. So it creates a new blueprint from this. The next minute. What we can do is now we can do a check here if minutes equals 24, return 0, because you can't, or return resources 4, 3, because that's how many you've made. Does this even work? Right. What if we have public void next minute? If we need something like this. Where we do this, but then we also have reset skip. Because skip should probably get copied over. That way we are correctly skipping what needs to be skipped, maybe. it's going though. Okay, no. Alrighty, so it is the next day. I've actually gotten off work a little bit ago and was able to now officially finish day 19. I kind of gave up after a while, after like 2 hours-ish of working on this. I guess the good news is I was at least close with what I was doing that night. I was on the right path, and I did continue on with recursion in a sense, but I kind of backed away from the original solution I was doing, kind of refactored and rewrote it. So what I'm gonna do is I'm just gonna go straight through and just kind of give the explanation of how these work. My solution is not fast. It takes a minute for part 1 and a full minute and a half for part 2. So it's not fast, it's not very efficient, it's a brute force, and I just do a lot of shortcuts and a lot of caching and slimming down of the brute force to make it work. So, but at any rate, day 19. So for this one, we're just kind of trying to find the most possible geodes we can open. Parsing this is just kind of a pain. For future years, I really should just make like a parsing system where I can just say, hey, here's the line, this is what the input is. Parse out the individual parts for this line, just give me a data object from that or a map from that. I really should do that, because doing stuff like this is just annoying. It's very annoying. So yeah, this just parses it out and it creates this blueprint data object. All this blueprint data object is, it just has all the individual costs associated with it, and then has this max robots field, which essentially is really just for the ore cost, because it gives me the max ore cost. Is this really actually even used? Do I use this at all? I should make sure I use it. Okay, I do use it. Okay, I want to make sure. But basically it gives me the max amount of resources that can be used by any process. So, you know, like basically all the ore cost is the max ore we could use by, you know, 1 bot creation. It's the max clay we can use by 1 bot creation. Max obsidian we can use by 1 creation. And then obviously there's no max geodes. But you'll see why this isn't helpful in a bit when we get to it. So it creates a blueprint data object here, and then it goes and creates a blueprint from this. This blueprint is actually what does kind of the storing of the actual data of like how many robots we have, how many resources we have, what money it is, and all that. That's what the blueprint is. So go ahead and create that, and we add it to this then blueprints for loop here. This again is all of the lines, does it for, and we have this. So now for part 1, we go through all of them and we say, all right, give me the max amount of geodes for this blueprint. And in the case of part 1, it asks for it in 24 minutes. So the way we do that is, first we check, are we at the max we want? Because if we are, then we'll just return how many resources or how many geodes we have, which is what we have here. Otherwise, we have a little cache here. This cache is basically just our blueprint, and all it's looking for is the minute, the robots, and the resources. So if we get to a point where in our cache we have a blueprint matching a blueprint we found in the past, return our cached value. That just cuts down on the number of branches and allows us to kind of simplify a lot of the branches as we get down into like the 20s and stuff. So it's pretty useful to know, because again, just saves us from doing a lot of computation by doing this cache. Just trades off cache or trades off our RAM for our computation. But then we get into the bread and butter of this, which is the 4 branching paths. The first branch, of course, is to make the geodes, or the geode robots, which is, again, they have an obsidian cost and an ore cost. So we check if we have enough of those resources. And then we also check this max robots here, which you'll kind of notice that, yeah, this actually isn't really necessary. I could have gone without that. I don't know why I didn't, but because there isn't a max robots for the geodes, because we want as many as we can. But say, you know, we get to the obsidian. In order to make this go a little bit faster, we know we can only produce one robot each minute. And because of that, it makes no sense to have for blueprint 1. Each geode robot costs 7 obsidian. It makes no sense to have 8 obsidian robots because we are then netting obsidian that even if we were making a geode robot every minute, we're still gaining obsidian. We only need 7 obsidian robots at maximum because that's all we can consume each minute. Basically, that means that we're producing as much obsidian as we are consuming as we can. So it just makes no sense to make more obsidian robots. So therefore, why worry about those paths? Why not just cut those paths out? If we already have 7 obsidian robots, don't make another. That path won't produce more geodes. So that is why we have this here, is again just to cut down on the possible branches and lessen the amount of computation we have to do. And so that's what all 4 of these do. Each one is just the different ore costs for the said robots. In that case, then, so for the geode robots here, we then subtract off the obsidian because again, resources here is just a list. It's ore, clay, obsidian, geode. As this comment here says, the same thing with the robots is ore, clay, obsidian, geode, as it goes there. And so that is what our 4 if statements do. It's just it checks to see, do we have the resources to make this robot? If we do, create a new blueprint. And we're branching. We're creating a branch. We have the option to create the robot, or we have the option to not create the robot. So it is creating a branch. That is why we create a new blueprint, which again just copies the data in this blueprint and then edits it to say, okay, let's make this robot, take away the resources, add the robot to be made, and then we add it to this whole blueprints list like it's added here at the end. And then this last one here is to basically do some more branching prevention. Have to make sure it's to make sure that we don't the max robots works for here, but we want to make sure that we don't have more. I believe it's more ore. I don't fully remember if this is necessary, but it's to make sure that we don't have more ore than we do have robots, I believe. Basically, it's saying we're not making sure we're not doubling our ore, I think, from the doubling from the maximum ore that can be consumed, and that the second robots. Oh, no, okay. Sorry, I remember this is now. This is just a shortcut to basically not flood the branch tree with just producing ore robots. I don't even know if we do need to produce more ore robots. I'm not sure. But the first branch of this is always it just goes ham on ore robots. It just makes straight ore robots for the first 24 minutes and just keeps doing iterations of that. And in order to kind of to kill all those branches there, we say if we have more clay than we do the max needed clay, instead of making more ore robots, making other stuff, if we don't have any clay robots, we should be making clay robots, because that's always the first thing. You always want to make sure you build up for your first clay robot, because that kind of is necessary to kick this whole thing off. So that is why that's there. Again, just kill branches where as possible, just to lower the amount of computation needed. So that one's a little bit trickier. I'm not sure if it's fully needed anymore, but it is there. But then we get into the heart of the actual tick cycle of each one. Again, each blueprint class that is only responsible for 1 minute before it recursively calls the new blueprint classes it made. Again, even if we don't do any decision, we still make a new blueprint, which is simply right here, just copying itself. But we go through all the blueprints. We increment the resources it has by how many robots it has. We then go through and make our new robots, increase our robots. That's why we have this robots making list here, so that way it doesn't influence the resources from the robots. That way they can be done after, but we can then calculate, the robots to make with the old resources. So that's why this is here. And then of course nulls it out, and then we increase the minute it's on, and then we get into here, this whole can make. going to try to do my best to quickly read over this and explain it. So this can make bit is to kill the branches where we're not going to have enough geodes to beat our current max geodes we've hit. Going back to the kind of the explanation of, you know, just making a bunch of ore robots, if our current maximum of geodes we have is 5 and we are at minute 20 of 24 and we don't have any geode robots, well, it makes no sense to continue this branching out if we can't physically make enough geodes with how much time is left. So if we need to make 5 geodes, but we have 4 minutes left, it makes no sense to continue this branch because this branch will not beat the maximum geodes we have currently found, so we just kill it there. That's why this just kills the branching. If we reach a point where it cannot physically be possible to make more geodes, then there is time remaining. It's not quite correct. As you can see here, this +2 is a pure magic number. It means nothing to me, but it works with this +2. I have some sort of logic issue somewhere in here, and by giving it a 2-minute buffer in robots, it works. So that's why it's there. Again, this isn't perfect. I've just kind of given up at trying to fix this all. It works with this is my solution. So that is what this for loop here is, again, just to kill more branches. And then last but not least, we finally get to the point where we now recursively call, continue the bread first search, get the geodes of all of the sub branches we've just made with the same max minutes. And then once we get the geodes from that, we add it to our cache, that way it can be accessed in the future. And then we check to make sure, is the geodes we have found greater than the max for this step. This max here is just for this minute and all the branches that this minute creates. Then after we go through all the branches for this minute, then we check against max and the max amount of geodes we have found, which actually this was, yeah, for here. This again just is here for, this probably should be, no, it's probably fine. This probably might be why it's actually having this max be here and not be on like a higher number. This might be why it has issues, but yeah. So there we go. That is how parts 1 and 2 work. Because part 2 is the same thing, just 32 minutes, but only the first 3 blueprints. Which is why it takes like 30 seconds per blueprint. The first one is like 2 seconds per blueprint. But there we go. Day 19 complete. It was a challenge. At least it was on the right path. But yeah, these last 5 days, 6 days, 20 through 25, might be a little rough. So there might be more like these where like I do it, give myself the 2 hours that night of, and then come back the next day and finish it off when I can. But yeah, time for me to relax for 6 more hours, and the whole thing starts over again for day 20. So anyways, you guys can watch this, you guys all in a few hours for day 20. Peace out.